So today's topic was on tornado simulator, and this is a tornado simulator that I normally bring to schools when we do in-person visits. So I apologize for the audio issues. I had no way to monitor whether we had audio or not out here, but I see we have levels now, so it looks like it's a good sign. I want to quickly recap. For those who saw it, it looked cool, but I'll explain a little bit what's going on. What the tornado simulator is doing is simulating wind shear. So each one of these pipes has a little hole that runs up and down each side. And each one of these is going to simulate the wind shear. You need two significant ingredients for tornadoes: wind shear and updrafts. Now, wind shear happens quite often. It's the wind changing direction with height. Updraft is basically air going from the ground into the sky. Now, a lot of people think tornadoes is all about hot air, cold air. That's not really necessary. What really is the hot air, cold air is cold fronts. That creates lift. But the things you need for tornadoes are the wind shear and the updrafts. And the United States is the tornado capital of the world. We get more tornadoes here than anywhere else. And when I chased tornadoes for 2 years, one of the things always fascinated with me about tornadoes was, even though we get so many, they're really incredibly rare. It's hard to get a tornado to form. I think a lot of folks will never ever see a tornado in their life. Most people won't. They're that rare because they only form for a few seconds, sometimes minutes, in a very small area. And chasing them is really incredibly hard as well, because it's hard to put yourself in the right spot at the right time to see a tornado. So it's an incredibly difficult thing to see, and most of us won't see it. So the simulator kind of shows you what tornadoes look like. And so the first thing I like to do is turn on the wind shear to show you how the swirling occurs at the bottom. You can see that swirling, and then you see the updraft take up the entire funnel. Now, we have a little bit of a cross breeze out here. The reason it breaks up, I'm outside, is tornadoes are so fragile. It takes very little to break them apart. So just a crosswind, inflow, something from another storm can disrupt these storms pretty quickly. So it doesn't take a whole lot to disrupt that. So there's a look at the circulation. And the thing about tornadoes that make them dangerous, I think most people think, okay, tornadoes are dangerous because of the wind. Really, for us, it's what the wind picks up and throws at you that makes tornadoes dangerous. That's why wearing a helmet is so important. Tornadoes pick up debris and throw it at you at whatever speed the wind is going. So the fact that tornadoes pick up debris and throws them around makes it dangerous for your head. So the walls between you and the outside protect you from debris. Floors above your head protect you from debris. The helmet protects your head. Everything is about protecting yourself from the debris, not getting sucked up by the tornado, which the Wizard of Oz and Twister all make us think that's the biggest concern. Most of us, if we ever got sucked up by a tornado, it's usually because we're in something that got picked up. If we got close enough to a tornado to get actually picked off our feet, that means we made it through a gauntlet of flying debris going at 600 or 700 miles an hour. Now, the other myth about tornadoes is that they cause most of the wind damage we see around here. Tornadoes are small. The average width is only about half a football field, or maybe even less than that. So isolated damage is usually tornado damage. Widespread damage, straight line wind damage, because that occurs over the whole thunderstorm. So when you see one tree down or one house damaged and the one next door fine, could be tornado damage. If it's a whole neighborhood or a whole swath, usually straight line wind damage like we had last Friday. Very good indication of a microburst or downburst is to see a swath of damage over several blocks across the city. Singular homes or singular trees, usually indication. Also, something with tornado damage, twisting is nothing to do with tornado damage. Trees twist in the wind all the time. You cut a tree down, you know it's going to twist in the weight. A stop sign on a windy day twists, just because anything vertical is going to twist. What we look for tornado damage is how the trees are laying, not crisscross. Are they laying towards the path? So if this was a tornado coming at us, trees would get pulled this way on this side of the tornado. They would get pulled this way on the other side of the tornado, and they would point towards a line, which would be the tornado track. So from the air, we can see a lot about tornadoes and their damage. So that's why aerial surveys with drones or from airplanes or helicopters, you can really tell if it's straight line wind damage or tornado damage real quickly by looking at it from the air. The other thing that makes tornadoes so fascinating is how they behave. This thing's just meandering around, dissipating, forming. It's hollow in the middle. If you can see, there's actually a little hollow area there. And notice how the outer part had collapsed. Now, the reason we see tornadoes is for two reasons. One, water vapor gets pulled in and we form a condensation funnel. Or two, stuff gets pulled into the tornado. The first tornado I ever saw in Ohio was a rotation in the bottom of the cloud, some swirling at the ground, but nothing in between. A tornado, by definition, is a rotating column of air in contact with the ground. Air is invisible. Unless there's something in it, you don't see it. So you don't always see a tornado, especially in drier climates. And the first tornado I saw looked like that, and we're like, is that a tornado? We saw the swirling up, and it went to a freshly plowed soybean field, sucked up the dirt, and it became this big dark funnel. So the other thing, tornado by definition means it's in contact with the ground. So I'm guilty of this. Tornado on the ground or tornado touchdown, it wouldn't be a tornado if it wasn't touching the ground. It's either a funnel cloud, which is a rotating column of air that's not in contact with the ground, or tornado. There's really no in between. So sometimes we say tornado touchdown or confirm. The tornado, by definition, has to be in contact with the ground or water or the surface. Other things we look for: wall clouds, which are rotating columns of air that are above, lowering in the cloud. Updrafts, we look for tail clouds. There's a lot of things that are precursor to tornadoes, but tornadoes are very distinct in that they rotate horizontally. Oftentimes people see vertical motion in a cloud and they think tornado. That's every thunderstorm. That's convection. So when we're looking for rotation in the cloud and people send me pictures and videos, I want to see violent rotation like this for it to be considered possibly a tornado. Just subtle movement like this is very weak. Up and down motion is typical, but rapid movement in the horizontal is really what we're looking for when we see a tornado. So apologize for the lack of audio earlier. Hopefully the visuals made up for it as I'm choking up now out here. But this is our tornado simulator. Hopefully in the future we'll be bringing it to schools instead of doing it online. Let me see if I can close this up a little bit. But this is how we can simulate a tornado, by doing wind shear and updrafts. And if you missed the first part, what's in there is just water, and we're using an ultrasonic humidifier to create a cloud, artificial cloud. So there's a tornado simulator. Sorry today we had a little audio difficulty, but hopefully you heard the last part here and you got to see the visuals earlier. Have a great day, and make